So my name's Shaun Mitchell. I go to GGC and I love doing this kind of thing. I actually did one of these workshops just a little bit ago about Git, but added some more to this. We're going to go over some Git basics and we're going to go over some stuff that you can do with GitHub. My goal for this is to, like I said, teach you some Git basics, the commands that you'll need for your day-to-day, for the most common workflows, the things that you're going to be doing, the Git commands that you need to know. It's not that many. Some best practices, namely to avoid collisions, to avoid overwriting other people's code. That's the most common error that you'll run into, especially when you're new to Git, is you'll push some code and overwrite someone else's stuff and you got to go back. It's a hassle. And for GitHub, we're going to look at contributing. That is one of the biggest aspects of open source philosophy, being able to contribute to other people's code, and GitHub is a big place for that. We're going to go over some features, some stuff that you can use GitHub for, especially when it comes to project management, working on your projects with a team. And then we're going to set up a GitHub Pages account, or sorry, a GitHub Pages website. To that end, if you would like to follow along for that section, because I'll be walking through it, and I thoroughly encourage you guys to walk along through it with me. I'm going to ask you to fork a repository. If you want to participate in that and you don't have a GitHub account right now, I would suggest going ahead and setting one up just while we're starting this off, so that when we get to that section, you'll have your GitHub account. Shouldn't take too long, maybe just a couple minutes. Your email, password. I think you have to verify the email. So anyways, with all that in mind, let's start with Git. So what is Git? It is a version control system. What does that mean? That means the keyword there is version. It's kind of like Google Docs. You know how it periodically saves your file, and you can go look through the history, see all the changes that that people made. That's what this is. And same as Google Docs, just like how you can see who made what changes, it tracks that with this. Except instead of one file, like with Google Docs, it's your entire project. It's like hitting save on your entire project, and you give that little save point a name, and then you can go look through your log, see all the different save points, and you can go back in time to a different save. If you accidentally break something, then you can go back to one of the points where it was still working. And because of all these different save points that you have with Git, they're called commits. You can also kind of mix and match them. If there was a file that was at a certain awesome place in one of these previous saves, one of these previous commits, you can just go pull that. But basically, yes, it tracks your project using versions or commits. It's got branches for separating and organizing your code. A really important aspect when it comes to coding and development in general is breaking what you're doing down into smaller, easier to digest pieces. Whether it's like writing a program, you don't want to put all of your stuff into one main method. You want to chop it up into little nice, easy to understand functions. It's a lot easier to wrap your head around it, a lot easier to make sure that things don't go wrong. And in this case, branches help organize your code. If there does end up being a bug somewhere, instead of trying to track down the bug in this one huge main part of your code, you have these different branches, these different sections where you can go be like, all right, there's a bug over in this branch. Let's figure it out. And you have a smaller section of code to go track it down. It helps with group collaboration. So with this, like I said, you know, everyone's edits, they can be seen. Sweet. Everyone's edits can be seen when you're looking through the log. You can share your edits with each other, your commits. Yeah, and everyone's changes. So if I change something and this guy changed something, Git has a really nice way of automatically merging our changes together. It typically does it magically and seamlessly for the most part. So branches are the first part we're going to start with. Every project has a master branch. All right, it should remain stable and bug-free. So this is something that I've seen a lot of people who are new to Git, they don't necessarily handle the master branch in the best way. And it's okay. Like for smaller projects especially, it doesn't really matter. But once you get out into industry, you want to follow some best practices, and that's what I'm here to help you out with. So to keep it stable and bug-free, what you want to do is not ever edit the master branch. What you want to do instead is create a branch of the master. What that means is basically you create a copy of the master branch, and then you edit that copy of it. So if we have our new feature branch, or we're implementing some new feature, we'll make a copy of the master, we'll call it the new feature branch, we'll edit new feature, and then once we're done editing new feature, after it's done and bug-free, then we'll go back and merge that into master. Only once your code in a separate branch is working and bug-free, only then, after you've tested it out, then you merge it back into master. That makes sure that your master branch always stays stable. All right, so oftentimes, like, you'll have a website, and that website is going to be based off of the master branch. So if you push some broken code to the master branch, you're breaking the website for potentially thousands of people. They're going to go visit it and see stuff broken and crazy, and someone's going to be very upset with you, someone above you. So that's why you create these branches, organizing your code out into separate individual parts that you test, and then only after everything's good, you merge. Helps with bug tracking, stability, organization, exactly. So here we've got a nice little infographic of what branching kind of looks like. You start off with your master branch, and then you'll go off and do your own thing a little bit. Someone else will go off and do their own thing. And then you bring your code back in. Once you're done and you've done all of your testing, you'll merge your work back into master. They'll merge their work back into master, and it's all streamlined. All fits together nicely and stable. The way these are just a couple of commands that you can use when it comes to branches. Git branch will show you all the branches and which current branch you're on. Git checkout-b creates a new branch and switches to it. And then, yeah, if I type git branch again, it shows me all the branches. We just added one, so now there's 2 there. And we're on the new feature branch. We switched branches. And so this is, again, just another like sort of explanation of what your branches, I think, should look like, best practices. This is sort of my own take on it. This isn't necessarily what you'll always see, but from my experience working with people working in industry, this is what I have found to work the best. You start off with your master branch. From there, you create a dev branch. And you still don't really edit the dev branch. Last slide, how I said that, you create a copy and then you edit that. You want to actually create a few copies deep before you start editing. You create your dev branch, and then from there, you create all your feature branches. So you want to create our Hill feature, our Christmas, our Lane feature. You want to work on these separately, and then you want to push them all to your dev branch. And then you want to test your dev branch, and then you push to master. But to further help reduce any errors where sometimes you might push some code that overwrites someone else's code, what I found works the best is to go ahead and create your own little personal branch that no one edits except for you. You're the only one who touches that branch. So if you're assigned to work on the Feature Hill branch, you'll take that branch and you'll create a copy of it. And you can call it, if you're Jack, you'll call it Jack FH, whatever you want to call it, doesn't really matter. You can call it puppies if you want. No one else is going to be working on it. It's just you. You'll put all of your code into there. Once you get that working, then you'll merge that into Feature Hill, and Jill's also working on the feature branch, so she'll push her code to from her branch into Feature Hill. And once you guys are both done and Feature Hill is complete, then you push that back up into dev. Same thing for the Christmas feature. Jack and Sally are working on that. And notice Jack doesn't have one repo or one branch for both of those features. He's got a separate branch for each feature that he's working on. So once he finishes his stuff for the Christmas feature, he'll push it to his repo. Sally will push her stuff. Once they're both done, they'll merge it into the Christmas branch. Once the Christmas branch is done, merge it back into dev. And Chad's just working on the Lane branch because he's Chad. So yeah, the git branch command lets you view all branches, create new branches, delete branches. Git checkout lets you switch between branches. And these are just a list of kind of an overview of some of the commands that you can run as far as branches go. Again, to view the current branch, other branches, git branch, delete a branch, create a new branch. One thing that's kind of common practice when you're done with a branch, especially something like a personal branch, is you'll go ahead and delete it. Once you're done implementing your stuff into a feature branch, you don't need your personal branch anymore. It's just kind of cluttering up space, so you'll end up deleting it. Feature branches, that's going to be up to your team if you guys delete those or not after you're done with the feature and merge that into your dev or master branch. But usually once you're done with the branch, you go ahead and delete it. Yeah, so to create a new branch, you can use the Git Branch New Feature command. Usually you'll see the Git checkout -b new feature. It's a little bit more complicated, but I mean, it's like an extra hyphen and a B. It's really not that bad. But that's usually what you'll see, because once you create a new branch, you usually want to start working in it. So one command to create and switch to the branch is just, it saves you like 10 characters, which means something. Cool. So merging is a big aspect of collaborative coding. You don't want your code to mess up someone else's code. So you end up using this git merge command so that you guys who are working on the same stuff can end up merging your code together in a way that isn't insane and that works and keeps bugs from happening. Usually Git will handle it for you. But every now and then, you'll want to use a merge tool, and basically it'll pop up a screen that says, hey, do you want to keep a line from your file or a line from their file? And you merge them together. To merge a branch, once you're done with new feature, because I know I've talked about this a lot so far, the command that you'll use to merge a branch with, say, master, once you're done with the new feature, it's a two-step process. First, you will check out the branch that you want to change, the one that you want to merge the changes into. So if we're done with new feature, we want to merge it back with our main master branch. We will check out the master branch, and then we'll use this Git Merge New Feature command, and it will take all of our new stuff that we added to the new feature branch and push it into master and merge it, so usually pretty seamlessly. Stash. This isn't necessarily always a command that you'll use the most, but it is nice to know about it when you need it. It's a pretty basic command. It comes up sometimes when you want to switch branches, but it's yelling at you. Yeah, in some cases, if you want to switch to like a previous version of your project, so that you can look at how a file used to be or whatever, sometimes it'll yell at you if you have changes that you haven't saved. So you can either A, save it, make a commit, or B, you can stash them if you don't want to, if you're not ready to make a commit yet. Basically, what a commit does is it takes your work and it puts it in this little box and shoves that box to the side and pretends that you haven't made any changes. And when you're ready, you can go ahead and bring those changes that you made back. Yes. Oh, and actually, that reminds me. I believe I meant to post the slides for this. Let me go ahead and do that for anyone who wants to. Oh no, we do not want to close the window. Let me go ahead and copy this and post this. Thank you for asking. I completely forgot to do that. Okay. Oh goodness. Lost our place. Here we go. Cool. Yeah, you can use the git stash command to hide all of the changes that you made. Then you can go do whatever you wanted to do, revert to a previous version. And then when you're done doing whatever you were doing that it didn't want you to do because you had unsaved changes, and you want to bring those changes back, you'll use this git stash pop command. So hide your changes with git stash, and that'll put you back to the last save version. And then when you're done, git stash pop, bring all of your changes back. Git Log. This is super useful for seeing who did what. If you've got a bug that cropped up, you can use Git Log to like try to help track down where that bug happened. Oh my, there we go. Okay, so sometimes it's useful to review all of the changes in your repo. These are some cases where you might want to do that. You want to go back to a previous project state. You need to look up which version you're trying to get to. You want to review who's been contributing. I know my professors have used this to see if I'm really actually contributing anything to the project. Review the progress of the project. You can create actually like one of these. Oh my gosh, you can create one of these like little nifty graphs here, actually, and that's going to pop up one of these windows that wants to keep sliding in. I'm going to show you how to do that. You can see what one single person has been contributing, all the changes that they've made. You can track a single file. There have been times where I knew that there was an error that popped up in some file, and I knew which file it was, but I didn't know when the bug happened or why. So I went and I followed the file, and I went to the last working state, and then figured things out from there. So let's look at what some of these commands look like. This is just your basic Git log. It just shows you a commit ID. So your saved versions, that is a specific ID to your saved version. And it shows the little message that you saved with it, the date and the author. But you can make it look a little bit fancier than that. You can add that little graph like I was talking about. And what these lines represent is those are different branches. So like right here, where it kind of goes off at an angle, that's a new branch being created. And then some more commits happen in here. And then that branch gets merged back into master. This is following a specific file. This -p option, what it does is it actually shows you the code that was, or the lines rather, that were added and subtracted. So here we're looking at this file face screenshot script I wrote. And so on this date, I edited this file. I took away these two lines and I added these two lines. So I can, go through and see like if there is a bug introduced to this file at some point, I can scroll through this and see where it happened. And then this is the one where you can follow a certain user, see all of the things that they've contributed. I've used this before where I knew that I was trying to find something that I did, but there was a bunch of commits from lots of different people. And I was just trying to find something I did. So I was following my own stuff. All right, and then so just an overview of a bunch of the commands that we went over. To clone a repository, you'll use the git clone command, and you'll give it the URL to your repo. View the branches, git branch, create a new branch, git branch, give it the name. Switch branches, you use the git checkout command. Update a branch, you can use git pull, and that will pull any changes that your teammates have made. Merge branches, that's the Git Merge Feature branch. You want to make sure that you check out the branch that you're merging into. Git Merge will merge that branch into whatever your current branch is. Temporarily hide the changes that you've made, git stash. A couple of log commands with the graph. I like it, it's pretty. You can see the actual file changes, the lines added and subtracted. You can view your status with git status and your changes with git diff. And I'll show you what that looks like here in a second. Basically, git status tells you what files have been edited, added, or deleted. Git diff will show you the lines that have been added and deleted. Your usual workflow is going to look like this. So this is the main takeaway from the Git section. once you sit down to work on a project with your teammates, these are the commands that you really want to remember. You're going to clone the website, or you're going to clone the repository. That's going to create a directory called repo wherever you run that command. So then you'll use the cd command, and that's whether you're on Mac, Linux, or Windows. They all have the cd command. You'll cd into that newly made repository. If you want to create a new feature, you'll use your git checkout command, git checkout-b feature chats, and then that'll create the chat feature branch and switch to it. Then you do your coding stuff. Once you're done, you will use git status, or even just along the way, you'll use git status, and that will show you all the files that you've changed. Then you'll want to use git diff, and that will show you all the changes that you've made, all the lines that you have changed. I know a lot of people feel like this is kind of an extra step, but I have caught so many bugs before they happened, before I broke something, by looking at git status and git diff. It's good to review which files you have changed and exactly what changes you're about to push. There have been times where I accidentally left some stuff in there that I didn't mean to. And because I was looking through the diff, seeing what all of my changes were, oh, that's unfortunate. I've been having some issues with my machine. I super apologize for that. But I guess at least if the audio is good, that's good. And you do have the slides there if you want to follow along. Hopefully, even though it's freezing, you can at least like you can see the current slide a little bit. Okay, awesome. So it's working for some people. Okay. Anyways, you always want to review what you're pushing to your repository, to your team, using the git diff command, so that you make sure you're not accidentally pushing something that you shouldn't. Make sure you're not leaving out anything that you do need to push. Once you've reviewed everything, you want to go ahead and commit. You want to make a save of your project where it's at. And then you can go ahead and check out the master branch, and you can do your merge. Actually, I meant to have another one in here. After you commit, you'll usually push, and then you can also check out the master, and then you'll merge. Okay, so the GitHub portion. I am excited about this one. This one's going to be cool. So what is GitHub? GitHub, it's a hub for Git repositories. See what they did there? Yeah, they're clever. So what can you do with GitHub? You can host an unlimited number of Git projects. You've got access control. You can create private repositories. You can give certain people access to your repository to change and edit code. You can create organizations and teams so that you guys can manage your projects together, create and track issues. You can automate deployments. So suppose that you've got a server where you've got your code hosted. You've got say your project is a website. You've got your website being hosted on a server, and then you've got the code for the website on GitHub. You can set it up so that when you push a change to GitHub, it will automatically deploy that to your server, to your website. It's got issue tracking. So if people find bugs, or if people want new features, or you want to assign a task to someone, you can manage that here. And kind of in the same vein, and actually able to integrate with that. We'll talk about that later. You've got project boards, which are pretty much the same thing as Kanban, for those of you who are familiar. You've got milestones to track your progress. Forking. So forking is a kind of a big part of open source. It's kind of foundational to open source, because open source is all about everyone coming together to make each other's code better, or everyone who wants to. Most of the time I just download it and use it, but sometimes I'll actually contribute to someone else's project, and that's where the strength of open source comes from. You can take someone else's project, you can copy their code, you can make some changes to it, and you can push that back for everyone else to use. And forking is part of that process on GitHub. Forking is the make a copy of their project part. A link is created between your fork repository and the original, so other people can easily find the original, and it makes it easy for you. Once you make changes to your copy, it's easy to go in and send a request for the original developers to pull your changes, which brings us to a pull request. Also, this is part of that open source philosophy. After you forked a repo, you make changes, add features, then you can request that the owners of the original repo merge your changes. Here we've got a project that I like to use. It's called Glow. It's awesome. And you've got some open pull requests because those guys don't check pull requests often or merge them. But, you know, slowly getting better. Issue tracking. I personally like to use this kind of as like the backlog. Again, for those of you familiar with Kanban, if you're not, basically this is just where you can track bugs, different issues, different tasks that you want to implement, features that you want to implement. You can give them various priorities, various labels. You can assign each of these to different members of your team, different people associated with your project. You can assign them certain issues. And you can also associate these issues. You can link them with your project board, which I believe is coming up next. Yes. All right. So for those of you not familiar with what a Kanban board is, it is this thing. Basically, you take all of the things that you want to do in your project, and you take a little Post-it note or something. That's something some people do. I never have, but you take each individual part of your project that you want to get complete. You want to make sure it's a small little task that goes towards your project, and you put it on this board. Everything starts off on the backlog. You just throw everything there. And then the stuff that's most urgent needs to get done, like, you know, this week, you put that in the to-do list. And then once you start one, you add it to the in progress list. And then once it's done, you can guess which column it goes to. And this just helps with organization, helps you keep track of where you're at, what needs to be done, and how much progress you're making. And GitHub has this in the form of what they call project boards. This is a fairly simple project board. You can make them, you can add as many columns as you want. What's cool is you can also, like I was saying earlier, you can associate different issues from the issue tracker with your project board. Here in just a few minutes, I'm going to actually take you to GitHub, walk you through it, and show you how that works on the website itself. But you can associate issues in the issue tracker with different cards on your progress board. You can automate it so that if someone comes to your repo and they file a new bug, they found something wrong, it will automatically get added to your Kanban board in the backlog or in the to-do column, whichever you specify. So that way, next time you go and look at your project board, see what needs to be done, it's automatically there. GitHub Pages is probably one of my favorite aspects of GitHub. It's simple compared to all the other awesome collaboration stuff that you can do with it. But it's just an easy way to keep, it's just another way, actually, this is a better way of saying it. It's another way that you keep all of your project stuff in the same place. GitHub Pages is basically a website hosting service provided by GitHub. And yeah, like I said, it keeps all your code, your issues, your Kanban, everything all in one place. And I really like that. It's just nice, convenient. It's all here. You can even add your own custom domain to it. They give you a GitHub domain to use to access all of your different pages. But if you want to, you can create your own custom domain and throw it in there in the settings. That way it looks just completely professional. No one would even know that you're using GitHub Pages. It supports HTML or Markdown-based sites. I'll talk about that more in a minute. Basically, I'm sure everyone has at least some idea what an HTML-based site is. Markdown means you're just using Markdown, like little hashtags and bullets and stuff to create your website, and it's super easy, super simple, ends up looking really clean. There's only a couple of cons. It only supports static sites. To a degree, we'll talk a little bit about a way you can kind of get around that, but it only supports static sites. So you can't have any like Python or PHP, any kind of backend language there that gets converted into HTML. And whenever you push, for some reason, it usually takes anywhere between like a minute and up to 10 minutes, according to GitHub's website, before those changes propagate. So it's a little bit annoying if you're trying to actively work on the website and then make sure those changes worked. You know, you'll want to make sure you're doing all of your testing locally. That way you can see your changes and then you push it. That way you don't have to push and refresh and wait 5 minutes and then push, wait 5 minutes. So yeah, other than those two things though, absolutely love GitHub Pages. One awesome use case for this is for blogging. And this is where we get into the support static sites. Jekyll is a blogging platform system that uses Markdown for your blog posts. It uses a templating system called Liquid, which allows you to, you know, if you've got a section of HTML that you're going to reuse in all of your pages, like say a header, combining header and footer, a header, a footer, that's going to be the same across all of your pages. You don't want to post that at, you know, the beginning of every file. So you put that in a template and it reduces your code. Not possible with just a static HTML website, but with Jekyll, you know, you can create these templates, you can create for loops, lots of different cool stuff to generate these pages for you. And then what you do, because like I said, GitHub doesn't, you know, run code. So how do you get HTML out of these templates? You can download Jekyll. It's some Ruby software. You download Jekyll, then you run this program on those templates, and then it generates the static pages for you. And that's what's called a static website generator. There's a lot of them that do that. But Jekyll's special because you don't have to do the download the software part and run it to generate the HTML, which you then upload to GitHub. GitHub actually supports Jekyll out of the box. If you upload a Jekyll website to GitHub, you don't have to convert it into HTML. You don't have to download Jekyll. You can just upload your Jekyll repository and it will do the conversion process for you. It will take all of your templates and it will convert them into static HTML. It's really cool. They don't support like Python or PHP or anything. They don't really do much of anything in the way of supporting any kind of backend language, but they do support this, which is pretty close. It at least allows you to, you know, reuse templates, reuse headers and stuff across all of your files. It's really nice. As a result, once you get your website set up, all you have to do to add posts to your blog is go into the posts folder. And you can do this completely through GitHub's file browser, like in your web browser. Go to the post folder, create a new file, throw your Markdown into it, bam, you've got a new post on your blog. And you just did it like a complete nerd, which I think is bonus points. If you're not interested in all the setup of Jekyll, there is a little bit of setup involved. There's actually this project called Jekyll Now, which I have linked at the end of this, which I like. It's literally a 3-step process. You fork the Jekyll Now repository, you edit a single file in there, a configuration file, and you're done. After you complete those 2 steps, you've got a blog that you can point people to. And all you have to do to add posts to it is, like I said, the part where you go to the post folder and you add a Markdown file. That's it. It's super simple. 2 steps, and then the last one is, you know, just adding posts, which you do continuously. So yeah, I've got that linked in here as well. Okay, cool. So we're not doing that just yet. we're going to, or yeah, why not? Does anyone have any questions or comments before we move on to doing a walkthrough on GitHub itself? Okay, I will take that as everyone is completely and utterly confused, or everything's good. Cool. So I'm going to post a link in the chat. This is a repo that I made, specific of the words, specifically for this workshop, to go over project boards and issues and the GitHub pages. So if you guys want, this is a part, oh, and pull request. This is a part where we can try out the forking, the process of forking a repo. So on this page, there is a button that says fork here. If you did go ahead and create a GitHub account, or if you've already got one and you would like to see what the forking process is like, go ahead, visit that link I posted, and create a fork of this repository. I believe, okay, yeah, so it's not going to let me fork it to mine because it's in mine, but it will let me, but I'm not going to add it to either one of those. Let me see, let me go ahead and, because I would like to walk through that process with you guys. Github.com, GitHub renaming. I'm going to fork this branch real quick. All right, so you click fork, you copy it to, I don't think it will ask you guys for this if you only have one account with them. Okay, awesome. Once you have forked your fork the repo, it should, like I said, it's got a link back to the original. And that will come up useful later. If you want to clone this repository to your personal computer, you can copy this. Trying to think. Yeah. You can install a tool called Git Bash. I'll go ahead and put the link for that in here. Git Bash, it's right here. This works for Mac, Windows, Linux. For Mac, you don't really need to install it. Git, I believe, and Linux, Mac and Linux both. Git comes with the operating system. All you need to do is open up a terminal. For Windows, I believe you do need to install this. Git does not come with Windows. So if you want to clone this, what you'll do is you'll open up a terminal, either Git Bash or a normal terminal for Mac and Linux. You'll copy this URL. And I just realized that you cannot see my terminal. So let me go ahead and switch to presenting a screen real quick. Stop presenting. All right, and then I'm going to present my screen. Present now. All right, screen 1. There we go. Okay, that way you guys can see my terminal this time. Awesome, there we go. Okay. So, so you'll type this command, git clone, and you'll post that, paste that URL, hit enter, clones it into this directory, and then you can cd into it. And if I look, here's all the files. At this point, this is where I would go ahead and start changing stuff if I wanted to. Let's go ahead and just do a quick, easy change. I'm going to edit their README file, renaming the default branch from master. Oh yeah, that's a thing. Apparently, GitHub and lots of people around the internets are, instead of calling the main branch master, they're calling it main. All right, makes more sense. Here we go. All right, hello world. Awesome. I added a line to their README. If I Remember, I told you want to always check your status. It tells me I modified the README. If I look at the diff, it will show me exactly what lines I edited. All right, and that looks good. There's nothing in there that shouldn't be. Everything's as I want it to be. I'll go ahead and commit it. Oh, I need to git commits. So you want to add the file. I usually use a slightly different command, but we'll go ahead and do it manually here. You'll manually add the file that you want to save. Usually what I end up doing though is git commit -am. What A does is it just takes all of your changes, everything that you did, go ahead and throw that into the commit. And I'll usually use the M option so I can add a little message here. Git commit just makes a save with everything I've changed with the message updated readme to say hi. There we go. And then I'll push it. And I'll push it. I hope my internet's working. Did the internet just die? Okay, cool. Oh man, it apparently didn't download with my credentials. That's unfortunate. Okay, okay, good. I've seen that IP before. Okay, well that's unfortunate. I don't want to. Let's see, what time is it? 20 more minutes. I don't even know if I remember my credentials because I'm like that, I guess. Why am I saying it out loud? I'll try one more time and then we'll just give up. Yep, okay. Well, that's unfortunate. I thought, oh, because I used, okay, this is what I wanted. Okay. Okay, I'll try that one more time. Git clone. All right, CD into the directory. Oh my goodness. Trying to do this too fast. Too fast. Okay, readme. Let's add hello world. Hello. Okay, git commit -am. You should check your status, but updated readme to say hi. Okay, and now I can push. There we go. Okay, so now if I go back to my repository, I'll refresh it. And look at that, there's my message. And now that I've done that, I can, let's see, we go to pull requests, new pull requests. Okay. So now I can go ahead and it'll show me the base repository, the one that's the original, versus my repository. And it'll show me the changes, which is just this. But apparently they don't want you to actually change what, they don't want you to change anything. So they aren't letting you do any pull requests, but that is what the process looks like. You go in, you clone it, you edit stuff, you commit stuff, then you go back to Git and you go to this pull request tab. And yeah, on here, basically at the bottom of this page, there should be a button that says something along the lines of send pull request. Okay, well, so let's go back to this UGAHacks 6 repo. I put a few cool things on here. We've got 2 docs folders. These are just folders that have like a little basic example website. We've got an issue tracker with 1 issue I went ahead and already made. Add GitHub Pages to a project. We want to turn this into a website before 10 o'clock. I'll be fine. It'd be so much cooler if it had a website. Oh my God. Okay. We have a Kanban board. So this is the one that I was showing you. And like I was saying, it's you can automate it with your issues. So that add GitHub Pages to project was automatically added to our Kanban board. If you would like to know how to get there, if your project doesn't have these nice fancy links, to get to the Kanban board, you go to the projects link. And then here, if you don't have any Kanban boards, you just say new project, and it'll create yourself a project board. All right, what else do we have here? And we've got the workshop slides. Okay. So let's go ahead and take care of this issue. If we go to the issues page, notice it is assigned to me. Okay, awesome. I see that some of you guys have forked it. If you guys want, go ahead and go through that process of making some edits. So after you've cloned it, or you don't even have to clone it. If you want, if I go back to my repository, notice after I've cloned it, I could actually have just gone to the README file. I can click this button here to edit it in my browser. I don't actually have to clone it to my computer. So go ahead and try that out. Go ahead and open up the clone that you made and make some edits to it, edit some file, and then commit changes. Commit directly to the main branch. Go ahead, you can add a update message if you want. It is recommended. And then once you've done that, go to pull requests and then new pull request, and send me a pull request, and I'll merge some of the changes that you guys make. Probably. So keep it PG-13. So let's go ahead and do this. So this project would be so much cooler if it also had a website. So the place where that's taken care of is over in settings. First, you do want to make sure that you have some HTML or Markdown stuff somewhere. I keep it in the docs folder, but it supports one of 3 places or 3 different types of places right here. So we can pick a branch. I did go ahead and make a separate branch for our Markdown page, which I'll show you in a second. Right now, we're just going to do the main branch, and we're going to do the docs folder. You can also have it just do your entire project repository if you want. I like doing the docs folder. That way, if I want to keep some files, like a README file, in the project, but I don't want that to be part of the website, then I can. I can put stuff that's like related to the website, some documentation, whatever, in the main root folder. And I can put all the website files in the docs folder. So I'm going to go ahead and save this. And now, if we're lucky, it's not going to take 5 minutes. Let's go ahead and open this up. And it is going to take 5 minutes. Okay. We'll come back and check that out. Now that we have gone ahead and done that, we will go ahead and go here. And I'm going to mark this issue. I'm going to make a comment. Added a website. Go ahead and close it with this comment. And here we go. The issue is closed. If we go back to the issues page, no more open issues. Can see it's there. It's closed. And if we go back to our Kanban board, let me go ahead and refresh this. Awesome. I don't have this part set up to be automated yet. What I can do, and I'll show you how this works with an issue in just a second. Manage automation. You can do this with any of the boards. Move an issue here when closed. So here we go. If we close an issue, it will automatically move the card associated with that issue from to do or in progress to close, to done. And there we go. So we'll just do that. Right now, we'll go ahead and manually add this. So let's go ahead and go back to our issues page. We're going to create a new issue. Let's say switch to Markdown websites. Submit. All right, I will assign myself this task, and I will give it the label of enhancement. It's a new feature request. Project, we'll add this to Kanban. And milestone, let's put it to website content. I didn't show you milestones. Milestones are part of issues. You can come over here. We'll look at the milestones, and these help you track the progress that you're making on your website. I can make a new milestone. We'll call it workshop complete. Give it a due date, and it's going to say today. Great milestone. Okay, and then over in the issues, as you create issues, I'll go ahead and attach this one to it as well. We'll attach this to website content and workshop complete. Okay, so just a one. There we go. All right. Cool. So now that we have it switched to Markdown website. Let's see if this went ahead and updated. Oh, is this not going to get updated in time for? Let's go look at the settings. It shouldn't have had any errors. Yeah, it says it's published, main, docs, index. Okay, there we go. Awesome. Why is that not? Okay, index. Got our index.html file there. So this is just a simple little website that I created using materialized CSS and a little bit of jQuery. 3 simple pages. Oh, and Vanta.js for the background, if you're curious. Cool. So now that we've got our website online, let's go ahead and take care of the next one. I'll go ahead and just kind of briefly show you the code for this. So it's got, I guess I could have done that over there too. But yeah, this is just your normal typical HTML. All right, and now let's compare that by going to our settings and changing this in pretty close to time. Changing this to use the Markdown site, and we're still going to use this docs folder. Save. All right, now let's go look at the what those files look like. So we're going to look instead of at the main, let's look at the Markdown site. So now notice instead of index.html, we've got MD and about MD. I'm not actually using these files. I could reference them, but I just haven't. Right now, it's just using these 2 files, index.md. Let's look at it raw. This is what Markdown looks like for anyone who hasn't seen it. This top part here, we've got 3 dashes. This little bit, this is called front matter. It's a way of describing the page. Layout tells it what template to use. This is done powered by Jekyll. GitHub uses Jekyll on the back end for any Markdown-based websites. Title sets the title for the page. Description, this will go into your description meta tag on the page. Then just a bunch of Markdown. So let's go ahead and see if that has updated yet. Index. All right, here we go. So I like this personally. This is fairly simple. You don't have to know HTML. You don't have to know a lot of fancy web dev stuff. All you need to do is be able to write a Markdown file, and then you can throw that onto GitHub, turn your GitHub Pages on, and there you go. You're good to go. Click About. It's let's refresh it. There we go. Awesome. Cool. So I've got a page here with like an easy little header, which I did just like this. And I don't know, personally, I think this looks really clean, and it's super easy. I love GitHub Pages. Like I said, it's one of my favorite features of Git. And one last cool thing that I want to show you about GitHub Pages is this theming engine. So if we come down here, we can also change the way our page looks with a theme. I really like Midnight's. Right? Yeah. Yeah. All right. So let's go ahead and select that theme. And now, if we go back here and we refresh, it should update this with the theme. Maybe not. Nope. I don't know if that's going to take a few minutes. Using the midnight theme. Yeah, maybe not. Okay. Oh. Anyways, like I said, this is just a really nice, easy, simple, clean way to build a website. Throw it online pretty quickly. Let's see if anyone has actually, okay, so someone did do a pull request. Awesome, let's see what they did. Added hello, okay, cool. So I'll go ahead and merge this pull request. Which I should have, no, I don't want to do that. Let's look at the files they changed first. So I did the same thing. They added hello at the end. If I didn't like what they did, I could write a comment, leave it for them, say, hey, I want you to do such and such a little bit differently, and then make a new pull request. But I'll go ahead and just merge this. Merge pull request, confirm merge. And now if we go back and look at the original repo that she copied, hello, there we go. And that's how open source contributions work. It's how we make each other's code better. That is awesome. Cool. Oh, and their name is right there. That is awesome for your resume. If you can go copy codes on the interwebs and contribute to open source projects, it'll look really good. And it'll show how many lines you've contributed. So anyways, I think that is everything that I wanted to cover. Does anyone have any questions? Anything that they'd like me to clarify? Anything that they want me to go over again? I know I did cover a lot in this presentation, so I'm open to any questions. Okay. There is a form there if you guys don't mind. My professors are collecting some information some information to help us improve our workshop skills. They told me I'm a horrible presenter and I need to be better. So go leave them some feedback. And what Linux distro am I using? I'm using Ubuntu, and I'm using Cinnamon. I really like Cinnamon. It's easy to add extensions and customize it. I like coding and deving and hacking and stuff, but I've gotten to a point where I don't want to spend all that time customizing my stuff. I want it to be nice and easy and simple. That's why I like something like Jekyll Now. Let me show you the process, anyone who's still here. Jekyll Now. Barry, there we go. Barry Clark Jekyll Now. So the process of creating your blog looks like this. Here's all the code to create this blog. I'm going to click fork. I've already forked it, so it won't let me do it again. But yeah, it's simple and easy, and I like that. I'm at a point where I like simple and easy. If I'm in the mood to code, I'll code. I'll code for 24 hours straight. But if I can make it easy, I like to make it easy. That's why this GitHub Pages is so awesome. Oh, it looks like it finally updated this a little bit. There we go. Okay. Changed the theme a little bit. All right. Well, I believe we're at the end of our time. If anyone has any questions or wants me to go over anything, I'm probably going to stick around for a few minutes. If not, please fill out the form. And I hope you guys enjoy the rest of UGAHacks. Have an awesome rest of your evening.